A very good morning to my students of class 10. So this is a continuation video on the same chapter, refraction of light. In the previous video we have seen how the bending takes place or the refraction of light takes place when it moves through a glass slab or in different medium. When light travels from rarer to denser, it moves towards the normal. When it moves from denser to rarer, it moves away from the normal. And the reversibility of light, the principle of reversibility. Whatever may be the direction of light, whether it is moving from rarer to denser or denser to rarer, then they will retrace a same path. In this video tutorial, we will learn how light bends through a prism, that is refraction of light through a prism. So before that, we should learn what is prism here. Let's understand prism. Prism looks like a triangle in a front view. When you will see from front, you will find that it's looking at a triangle having the terminals A, B and C, right? So it has two rectangular surface. You see, I have drawn one prism here. So it has two rectangular surface, that means A, B, E, D. This is one rectangular surface here, and A, C, F, D. This is the second rectangular surface. When these two surfaces, when they are inclined with certain angle, that is called angle of prism, then they will form a prism. Okay, two rectangular surfaces when bounded with each other forms a prism. So let's see what is the definition of prism. A prism is a transparent refracting medium bounded by two plane surfaces with an between them. So here angle A is called angle of prism. Okay, see, I have drawn one prism here. So angle A is the angle of prism here. Okay, it is made up of two rectangular surfaces. From the diagram you can see this is a prism ABC. LM is the incident ray, MN is the refracted ray, and NK is the emergent ray. When this incident ray is falling on the refracting surface AB, it bends towards the normal, making an angle of refraction R1. And when it moves from denser medium to rarer medium, this is air and this is glass, so it moves away from the normal. Okay, and where A is the angle of prism. Now you see here, when this incident ray falls here, it changes its direction. But if you remove this prism, the original path of this incident ray will be this, right? This is the original path. You can consider this one as LMP. This is the original path. And if you produce back this emergent ray, then an angle is subtended between the produced incident ray in forward direction and produced emergent ray in backward direction. This angle is said to be as angle of deviation. So this angle of deviation, it is denoted by del, which is subtended between produced incident ray and emergent ray. Okay, where LM is the incident ray, MN is the refracted ray, NK is the emergent ray, R1 is the angle of refraction, R2 is the angle of incidence here in the prism, and del is the angle of deviation, and I2 is considered as angle of emergence. Okay, so this angle of deviation, it depends upon certain factors. So the first factor upon which it depends is the angle of incidence. So angle of incidence and nature of the material and color of the wavelength of light. So you see, first factor upon which it depends, this angle of deviation depends, is angle of incidence. Now how it depends, you see, if I plot a graph between angle of incidence in x-axis and angle of deviation in y-axis, the angle of deviation decreases with increase in angle of incidence to a certain limit, like up to here. You see, let us consider this is del m. Angle of deviation is decreasing on increasing angle of incidence up to del m. So at this point we say this is angle of minimum deviation. So here I1 is equals to I2, that means angle of incidence equals to angle of emergence. But after this point, this certain limit, again we see that angle of deviation increases with increasing angle of incidence. Okay, so this is the first factor upon which the angle of incidence varies inversely up to a certain limit with that of angle of deviation. Again, after del m, after this point, we see that angle of deviation and angle of incidence becomes directly proportional. It increases with increasing angle of incidence. Now in the second factor, it depends upon nature of the material, like the material of what this prism is made up of. If the refractive index is more, it has been seen that it varies accordingly. So from the diagram it is clear the angle of deviation is formed between produced incident ray and produced backward emergent ray, angle of deviation, that is denoted by del, right? So this angle of incidence, it depends upon first factor, that is angle of incidence. Angle of incidence increases, the angle of deviation goes on decreasing for a certain limit. Okay, for a certain angle of incidence until it attains the minimum value, which is known as angle of minimum deviation, which I said that is del m. So in the diagram also you will see that del m up to this point the angle of deviation decreases with increasing angle of incidence. Then after this again both increases simultaneously. Okay, so here in this diagram at this point del m always I1 equals to I2 and R1 becomes equals to R2. Okay, so R1 was between the refracted ray and the normal, and here this refracted ray, that is R2, with the other normal which is drawn at the refracting surface AC. Okay. Next, it depends upon material of the prism. The refractive index of a prism depends on its material. If the refractive index of a prism is greater, it will produce greater deviation. That means angle of deviation is directly proportional to material, that is refractive index of a prism. Next, it depends upon the color or wavelength of light, that is greater the refractive index, greater is the angle of deviation. So again we'll find that angle of deviation decreases with increase of wavelength of light. That means for the red light whose wavelength is maximum, angle of deviation is minimum. Okay, and the next factor, that is the last factor on which this angle of deviation depends, it depends upon angle of prism. Greater the angle of prism, greater will be the angle of deviation. So what are those factors? First factor is angle of incidence, next factor is material of the prism, and third factor color or wavelength of the light, and the fourth factor, that is angle of prism. So these are the factors upon which the angle of deviation depends. Topic we have real and apparent depth. In the diagram, let us consider this is a swimming pool, right? And this is air and here water. Inside that swimming pool we have a coin. This coin is viewed from outside, that is from rarer medium. Suppose you are viewing from here, you are viewing from outside, then you will find that one light is going straight from this coin, and a light, now it is moving from denser to rarer, right? Because you are viewing, the object reflects the light. So this light is coming out, and as soon as it strikes the interface of air and water, it will move away from the normal, right? So here you see this is a normal. Actually the light seems to come from point D. This is the actual deviation of that light. So that is why the coin seems to be raised up of a distance x. This is the actual depth of the swimming pool, and this is the apparent depth, right? This is the apparent depth. So when you view from outside, you will find that the coin has raised up due to this refraction. Okay, so refractive index is given by n equals to real depth by apparent depth. Okay, so what is the real depth? That is the thickness. Let us consider actual depth is t. So if I consider as real depth as t, then what is the apparent depth? What is the change in distance here? So from O means the object, from O to D it is x. So what will be our this distance? If I consider this point to be as x, then xd is t minus x. This total is t and this is x, so this is t minus x, right? So apparent depth is our t minus x. Nothing is there, means 1. Now if you reciprocal here, just if we interchange, then we will get 1 by n t minus x by t, right? We have just interchanged both sides. T by t minus x by t. This is 1 by, I have separated this one. Now t and t got cancelled. So what we will get here? 1 minus x by t equals to 1 by n. This expression can be rewritten as 1 by n 1 minus x by t, here same relation. So x by t equals to 1 by minus 1 by n, or x equals to t 1 minus 1 by n. So this is the shift, means how much distance the coin has raised up, that can be easily found by this formula. Okay, so what is apparent depth here? Actual and apparent depth here. So when the light was moving from denser to rarer, as it was moving away from the normal, so bending has taken place here. Now object seems to come at point D. Initially when you are viewing from outside, the object was at O, that is at the bottom of that swimming pool. But when you are seeing that object from rarer to denser, here object seems to raise up. So how much distance it has raised up, that can be easily found by this formula, x equals to t 1 minus 1 by n, where t is the actual depth, okay, and x is the net lateral shift, you can see the shift of that coin. So these are the few applications of refraction of light. See, an object is immersed in the water, but when you are viewing from outside, that object seems to be bending, it seems to get bent. So when a stick is immersed in a glass of water, in that case also we see same phenomena, that the stick seems to get bent as the light is moving from denser to rarer. Okay, light falls on that stick and it seems to get bent. Not only this type of sticks are bending here, but we also see twinkling of stars. So the atmosphere above us is denser. Now it goes on decreasing as it moves away. So in far position where the star is situated, at that position the density is very less, and the light which is coming from star, it passes through different densities of light. So as it passes from different densities of light, their bending of light takes place. Due to this bending, what happens, the actual position of star, you see it is at A. So due to bending, now when you are looking from the earth's surface, it seems to come from point C, and due to movement of wind or air, the density keeps on changing and it seems to be coming from point B. So in this way the stars gets on changing its position. Due to change in position, it is appears to get twinkle. Okay, so this is the reason that we see a twinkling star at night. You need to write some questions in your exercise book. You will be noting down these questions. What is meant by refraction of light? What causes refraction of light? Explain the refractive index of a medium. All these questions I have given as a note. You will refer my previous videos, so you will get and you will note down in your exercise book. On what factor does the refractive index of a medium depend? What is the principle of reversibility of light? Define the following terms: incident ray, emergent ray, refracted ray, angle of incidence, angle of refraction, and angle of deviation. The refractive index of water with respect to air is 4/3. What is the refractive index of air with respect to water? Okay, laws of refraction. And question number 9 you can just omit. How will you prove the laws of refraction experimentally? This one no need to write. Okay, you can omit this question. What is lateral displacement? State any 3 factors on which it depends. What is the unit of refractive index? It has no unit. Okay, as it is a speed of light in air or vacuum to that of given medium. We know this one. It is a ratio of speed of light. What is the refractive index of vacuum? That is 1. Already the answer is given in your book. Define a prism. For which color of white light the refractive index of a transparent medium is the least? That is red. In this video also we have learned that if the wavelength of light is maximum, so angle of deviation will be least. Okay, how is the refractive index of a medium related to the speed of light passing through it? Up to question number 15 you will be writing. Okay.